Welcome back to the 3ds Max Basic Modeling online course. I'm your instructor, Li Ruijing. In the previous lesson, we completed the mid-poly model of the token. In this lesson, we'll perform add supporting edges on that mid-poly model and optimize the model for the final asset.
Instructor, do you have any tips for adding supporting edges to the token?
Open the project specification for this assignment and look at item 2. You can see it illustrated here. The first editable poly layer is the mid-poly model. The second edit poly modifier is the adding supporting edges layer. Its command is the same as that of an editable polygon, but it's specifically used for adding supporting edges. The third turbo smooth modifier is used to increase the polygon count. By working in these 3 steps, the controllability, flexibility, and reversibility of high poly modeling are significantly improved. Now, let's get started. First, let's check if there are any triangles in the mid-poly model that could affect adding supporting edges. Go to the editable poly level. Turn on Show End Result. And check the model's edge flow. Here, you can see a triangle. Use the cut tool to split the triangle into quads. Delete the unnecessary edges, then adjust the vertices for a smooth flow. After that, add an edit poly modifier to the model. This will be our adding supporting edges layer. Place this layer below the symmetry modifier. This is because the gold part only requires edge control for 1/4 of the model. The other 3/4 can be mirrored. So, the symmetry modifier should be placed on top. It can affect the 2 layers below, including both the mid-poly and supporting edge layers. Now, expand the Edit Poly rollout into 2 columns. Click the small white triangle button at the top. Expand the ribbon panel. Activate Swift Loop. Add a new edge loop along the existing structural edges. Notice here that, after using Swift Loop, the loop didn't continue around the sharp corner. Right-click and use the Cut tool to connect it to the top. When using Swift Loop, always watch for sharp corners. In the concept art, you can see a distinct hard surface transition here, so we need to use 3 supporting edges to protect this area. In this case, we'll modify the topology using the Cut tool. After cutting, select the 2 small edges in the middle. Press Ctrl plus Backspace to remove them. Now take a look. The 3 polygons I've selected are all quads, and the hard edge transition is well preserved. This is the correct way to add supporting edges. Let's check it under the Turbo Smooth modifier. Move the Turbo Smooth modifier to the top of the modifier stack. It should affect all layers beneath it. Use the Cut tool to connect this small triangle to the top. Then activate Swift Loop. Add edge loops around other structural transitions. The new edges from Swift Loop don't look quite right here. That's fine, we can fix them manually. First, select these 2 vertices. Press Ctrl plus Shift plus E to create an edge between them. Right-click and collapse them to a single vertex. Then double-click to loop select the redundant edge. Press Ctrl plus Backspace to remove the edges and vertices. Now, the topology in this area looks clean. At the lower area, use Swift Loop to add a new edge loop. Connect the diagonal edges. Select and remove the unnecessary edges with Ctrl plus Backspace. Now, everything is converted into quads. Activate Swift Loop again and add an edge loop to the inner ring. Exit Sub-Object Mode. Turn on the Turbo Smooth icon. Check the smoothed result. You can see at the upper right interior corner, the edge transition has become over-smoothed. so we need to add supporting edges here. Activate Swift Loop. Add 3 supporting edges around the corner. After that, optimize the edge flow again. Connect the diagonal edges, then double-click to loop, select the redundant edges, and press Ctrl plus backspace to remove them. Now, the Turbo Smooth result looks much better. Continue using Swift Loop. Use the Cut tool to connect the sharp corners to the top. Add another edge loop with Swift Loop. Do the same for the transition at the bottom of the token. Loop this structural edge as well. After adding the loop, you'll notice the upper edge spacing becomes too wide. Press Ctrl plus Z to undo. Run Swift Loop again. The top looks good now, but the spacing below has become a bit narrow. We can fix that manually. In the Edit Geometry rollout, enable Edge Constraints. Select the lower area where the supporting edges are too close together. Move them slightly apart. Double-click to loop, select the lower edge loop. Hold Altitude to deselect specific segments. Move this section outward slightly. After that, double-click the bottom edge loop again. Loop selected. Hold Altitude to deselect specific segments. Adjust the edge position slightly. Now, the edge spacing looks balanced. After adjusting, set the constraint to none. There are some unnecessary edges at the top. Let's finish adding supporting edges along this structural line before cleaning up the topology. Right-click and activate the Cut tool. Cut a new edge along this structural line. You can see there are clearly some unnecessary edges here. Select the redundant edge. Press Ctrl plus backspace to remove the edge and vertices. Then enable the Turbo Smooth modifier to check the result. Most of the structure looks good. Some areas are still too soft, such as this middle seam. We haven't added supporting edges there yet. Right-click and use the Cut tool to add new edges. Retopologize the triangular section. Remove the unnecessary edges in the middle. Apply the same technique to the bottom part. Now, use Swift Loop to add a supporting edge loop around the entire perimeter of the token. Otherwise, the edges will become too soft when smoothed. Do this for every critical edge. Ensure all the necessary edge loops are in place. At the sharp corners, you need to cut manually. Cut from one side of the corner to the other. This is the correct way to handle sharp corner topology. After finishing, exit the sub-object mode. Enable the Turbo Smooth modifier. Rotate the model to inspect it. You can see that every structural area of the gold section now has clear, defined transitions. This looks good. Now, let's add supporting edges to the fire character. Activate Swift Loop. Add an edge loop to reinforce the thickness transition. Then select the central polygons. Right-click and choose Bevel. Set the bevel height to 0. Reduce the bevel outline amount slightly. See, the bevel operation also creates supporting edges for sharper transitions. So there's flexibility in how you add supporting edges. The Bevel tool can also serve this purpose. Enable the Turbo Smooth modifier. Set the Turbo Smooth modifier's iterations to 2. Set the Turbo Smooth modifier iterations for the gold section to 2 as well. Rotate the model to inspect the result. Now, we'll move on to the rope section. Select the rope model. Convert it to an editable poly. Attach all the blue rope segments together. Apply a Turbo Smooth modifier. The rope loop and the main body don't require adding supporting edges. Only the rope tassels at the bottom have become too soft after smoothing. They need additional supporting edges. Add an Edit Poly modifier as the supporting edge layer. This modifier must be placed below the Turbo Smooth modifier. Double-click to loop select the structural edges. Right-click to open the chamfer setting dialog. Chamfer the structural edges to create 3 supporting edges. Then double-click to loop select the edges in the perpendicular direction. Chamfer these edges into 3 segments as well. Enable the Turbo Smooth modifier again. Now you can see the rope tassels have well-defined edges and clear form. The front reference plane is no longer needed. We can delete it. Now rotate the model to inspect the final result. Our high poly token model is now complete. Next, let's make the final adjustments according to the project specification. First, in 3ds Max, the system unit must be set to meters. Let's check the unit setup. It's correctly set to meters. Remember to always set the unit system before starting any modeling work. Second, each model should maintain a separate supporting edge layer and a Turbo Smooth layer. We've already implemented this correctly. Let's examine the gold section. There's an additional symmetry modifier here. As we mentioned earlier regarding symmetry, place it above the supporting edge layer. This way, you only need to model 1/4 and let symmetry handle the rest. Then allow the Turbo Smooth modifier to affect all layers below it. That gives us the final smoothed result. Third, every model's pivot point should align with the main body. Positioned at the center bottom of the primary model, reset the X, Y, and Z coordinates to 0. This ensures all parts of a complex high poly model share a unified coordinate system. In this token model, the gold section is the main body. Its X, Y, and Z coordinates are all set to 0. Let's check the plane model. The Z-axis coordinate isn't aligned correctly. Enable Effect Pivot Only and reset the Z-axis to 0. Then select the Fire Character model. Reset its X, Y, and Z coordinates to 0. Next, select the rope model. Reset its X, Y, and Z coordinates to 0 as well. This way, if any component is accidentally moved, you can simply reset X, Y, and Z to bring it back to its correct position. It will automatically align with its original placement. This is an essential workflow habit when working with multi-component models. It's a good habit that ensures accuracy and consistency when working with complex models. That completes the high poly modeling of the token. In this project, you've experienced how different modeling workflows can apply to the same concept art. Do you now have a clearer understanding of the differences between low poly, mid poly, and high poly models? That's all for this project. See you in the next one.